Right now you are sitting inside an invisible river. It is flowing through the walls around you, through the floor beneath you, through every wire and cable in the building you are in. You cannot see it, you cannot smell it. But the moment it stops, everything around you goes silent and dark. It is electricity. And the strange truth is, most people have no idea what it actually is. You use it every second of every day. Your phone, your lights, your brain, yes, your brain, all run on it. But if someone asked you to explain what electricity actually is, most people freeze. They say something about lightning or wires or maybe Benjamin Franklin and a kite. And those answers are not wrong. They are just the surface of something much deeper and far stranger than you were ever taught. So what is it? The real answer requires you to go smaller than you have ever gone before. Everything around you, the chair, the air, your own hand, is made of atoms. You already knew that. But here's what most people gloss over. Every single atom contains particles with electric charge. Inside the nucleus there are protons and they carry a positive charge. Orbiting outside that nucleus are electrons and they carry a negative charge. In most atoms those charges balance perfectly. The atom is neutral. Nothing flows, nothing happens. But in certain materials, especially metals, something unusual occurs. The outer electrons are not tightly bound to their atoms. They float, they drift. In a copper wire, for example, there are roughly 8.5 times 10 to the 28th power of these free electrons per cubic meter. That is a number so vast it is almost meaningless. What matters is this: those electrons are loose. They are ready to move. Now imagine you connect that copper wire to a battery. The battery creates a difference in electric potential, a kind of pressure between its two ends. On one end, electrons are being pushed. On the other, they are being pulled. And so those loose electrons in the wire begin to drift, not fast, shockingly slowly in fact, at a rate of about 1 centimeter per minute. That drift is called electric current. Here is where it gets strange. If electrons only move 1 centimeter per minute, why does your light switch work instantly? The answer is one of the great hidden surprises of physics. When you flip that switch, you are not waiting for an individual electron to travel from the power plant to your bulb. You are doing something more like filling a pipe with water. The moment pressure is applied on one end, water moves at the other end almost immediately because the pipe was already full. The wire was already full of electrons. The signal moves at close to the speed of light. The individual electrons barely shuffle. This distinction confused scientists for decades and still trips up students today. This is where Michael Faraday enters the story. In 1831, Faraday, a man who had almost no formal education but one of the most intuitive minds in scientific history, discovered something that would change the world forever. He found that if you move a magnet near a coil of wire, electrons in the wire begin to move. No battery, no chemical reaction, just motion and magnetism producing electricity from thin air. What Faraday had discovered was electromagnetic induction. And the reason it works pulls back a curtain on something fundamental. Electricity and magnetism are not two separate forces. They are two faces of the same force. Move electric charges and you create a magnetic field. Move a magnetic field and you create electric current. They generate each other. They are bound together at the deepest level of physical reality. James Clerk Maxwell formalized this in 1865 with 4 equations, now simply called Maxwell's equations, that unified electricity and magnetism into a single theory of electromagnetism. Those 4 equations also predicted, as a side result, the existence of electromagnetic waves. Light itself turned out to be one of them. Radio waves, microwaves, X-rays, all the same thing, just at different frequencies. Electricity did not just power civilization. Understanding it revealed the true nature of light. But now comes the twist that almost nobody knows. In everyday life, we talk about electricity as if it flows through a wire the way water flows through a hose. The wire carries the energy from here to there. This is intuitive. It is also technically wrong. In 1884, the physicist John Henry Poynting showed that the energy in an electric circuit does not travel inside the wire. It travels through the electromagnetic field surrounding the wire. The wire guides the field. The electrons inside nudge and bump and signal, creating a field in the space around the conductor. And it is that field in the empty space outside the wire that carries the energy from your power source to your device. A recent video demonstrating this with circuit simulations went viral precisely because it breaks the mental model almost everyone has held since childhood. The wire is not a pipe. It is more like a track and the energy is riding invisibly alongside it. Your ancestors felt this force long before they understood it. The ancient Greeks knew that if you rubbed amber, fossilized tree resin against fur, it would attract small objects. The Greek word for amber is electron. That attraction is static electricity, the buildup of excess charge on a surface. For 2,000 years, that party trick was the extent of human interaction with one of the universe's fundamental forces. The first creatures on Earth to truly exploit electricity were not humans. Electric eels, which are not actually eels but a species of knifefish, evolved specialized cells called electrocytes, stacked in columns like living batteries, capable of generating up to 860 volts. They use electricity to hunt, to communicate, and to navigate in murky water. They evolved this ability hundreds of millions of years before a single human being walked the earth. In a very real sense, biology got to electricity first. Your own body runs on it. Every thought you are having right now is an electrical signal. Neurons fire by allowing charged ions, sodium, potassium, calcium, to rush across their membranes, creating a brief pulse of electrical activity that travels down the nerve fiber and leaps across synapses. Your heartbeat is triggered by an electrical signal from a cluster of cells called the sinoatrial node. When that signal is disrupted, when the heart's electrical system misfires, a defibrillator works by sending a controlled shock to reset it. Electricity restoring electricity. The neuroscientist Antonio Damasio spent years studying patients with brain damage and found something that reframes the way we think about thought itself. Emotion and rational decision-making are not opposites. They are both electrochemical processes, inseparable and interdependent. What we call a feeling is at one level of description, a pattern of electrical signals cascading through interconnected neural circuits. This does not make your feelings less real. It makes electricity more profound. So what is electricity? At its most fundamental level, it is a property of matter itself. It is the force that holds atoms together, the force that makes chemical bonds possible, the force that drives your nervous system, powers your cities, and when unleashed by the sun in a thunderstorm, writes fire across the sky. Benjamin Franklin did fly that kite. In 1752, he proved that lightning was not divine punishment or supernatural fury. It was the same force he had been playing with in his laboratory, scaled up to an almost incomprehensible magnitude. A single lightning bolt carries roughly 1 billion joules of energy. It heats the surrounding air to 5 times the temperature of the surface of the sun, and it lasts about a third of a second. You flip your light switch tonight and the lights come on. It seems ordinary, unremarkable, something you have done 10,000 times. But what actually happens in that moment is the organized movement of particles so small they defy imagination, guided by fields that extend through empty space, shaped by forces that unite light and magnetism, and the beating of your own heart into a single invisible river that has been running since the first charged particle was born in the early universe. Right now you are sitting inside that river, and you always have been.